This video is about phase change. The three most common states of matter are solid, liquid, and gas. There is also a plasma state, but since it is not part of the IB physics syllabus, we'll just focus on the solid, liquid, and gas states. When a substance undergoes a phase change, it changes between two of these three states. When a solid melts, it becomes a liquid, and when the liquid freezes, it becomes a solid. When a liquid boils, it becomes a gas, and when a gas condenses, it becomes a liquid. In some cases, solids can change directly into a gas by sublimation, and gases can change into a solid by deposition. Again, we won't discuss this phase change here in detail. Let's see what happens when energy is supplied to a solid over a certain period of time. The temperature versus time graph for this situation looks like this. Here we have time on the horizontal axis, but you will also see graphs with energy on the horizontal axis. In this context, it is practically the same thing. The key is that energy is supplied over a certain period of time. As you can see, this graph has 5 different sections. Each section shows us something about the behavior of the substance during that time period. Let's examine each section. As we mentioned, we start by supplying energy to a solid. In other words, we are heating a solid object, which could, for example, be an ice cube. In the first section, the temperature of the solid is increasing. Here, the kinetic energy of the molecules increases, and as a result, the molecules in a solid vibrate faster and faster. In addition to an increase in kinetic energy, intermolecular potential energy also increases. As a result, the molecules in the solid move farther apart. When the solid reaches its melting point, the second phase begins. Here, the solid is melting. An important point here is that the kinetic energy of the molecules does not change, so there is no temperature change. We can also see this from the graph, since here the line is horizontal. During this period, all energy that is supplied to the solid goes into increasing the intermolecular potential energy of the solid. As a result, molecules and groups of molecules start to separate from each other, and even though they are still close to each other, now the molecules are more free to move around. In other words, the solid melts and becomes a liquid. Once all the solid has melted, we enter phase 3, where the temperature of the liquid is increasing. Here again, there is an increase in kinetic energy, so the speed of the molecules increases. Intermolecular potential energy also increases, and as a result, the freely moving molecules and groups of molecules move even farther apart. Note that the forces acting between the molecules are still significant, but much lower than in a solid. When the liquid reaches its boiling point, we enter section 4. Here, the liquid is boiling. Once more, there is no change in kinetic energy, so no change in temperature. The graph is horizontal. All the energy goes towards increasing intermolecular potential energy, and as a result, molecules completely separate from each other, so intermolecular forces become insignificant. We'll discuss this further when we learn about ideal gases. Once all the liquid has vaporized and the substance is in a gas state, we enter section 5. Here, the temperature of the gas is increasing. Kinetic energy, hence the speed of the molecules, increase, and since the molecules are completely separated, we can assume that here intermolecular potential energy does not change. Again, we'll talk more about this when we get to ideal gases. This completes the final video in subtopic 3.1 and our discussion of phase change. In the first video of subtopic 3.2, we'll learn about pressure.